Algebra 2 students, in this video today we will be taking some previous knowledge that you've learned and we're going to apply it to an assortment of different problems. Now, this is really a good lesson for two reasons. First of all, it's going to reinforce what you've learned in the past. In other words, it's going to review, which is good for you. Secondly, it makes you view former topics from a totally different angle that you've not seen them before, so that helps you understand the math further, okay? Your heading today is taking zeros further, okay? Lesson 9.6, and be sure and include today's date. We're going to take this zeros topic a little further today, okay? Lesson 9.6, and be sure and include today's date. Here we go. Let's jump right into this. We are going to look at different problems, okay? And I'm going to show you how they tie into what we've already learned. And I'm going to show you how to work these problems out. Also, at the very end of the video, I'm going to give you a couple key sentences to write down that kind of help tie things together in the end. Okay, here's the first problem I would like us to work on. Please write this down. Write a polynomial function that has the given zeros with the lead coefficient of 1, okay? Write a polynomial function that has the given zeros right here with a lead coefficient of 1. Now, while you are copying this down, please listen to me and let me ramble, okay? If I gave you a function like this, don't write this down, just watch. If I gave you a problem like this and I said find the zeros, you know what to do. You always try to factor first, okay? And you would factor this and you would get this right here. Trust me, that's correct, okay? There you go. Then you would take this parenthesis, set it equal to 0 and solve, and you would get 5. Then you would take this parenthesis, set it equal to 0 and solve, and you would get this. Got it? So there's your two zeros. Now, do you notice something peculiar and interesting here? Notice that one of the zeros is 5. Do you see that? Remember, if you took x plus 5, set it equal to 0 and solve, you get negative 5. I don't want to lose you guys here. Take this parenthesis, set it equal to 0 and solve, you get this. There's your zeros. Okay, now your 0 is 5, but notice in the parentheses we have a negative 5. Opposite. Notice your 0 is negative 4, but in the parentheses we have a positive 4. That's always going to happen. Always. So if I ask you to write a polynomial function and I give you the zeros, can you not just change the signs of the zeros and put them back into the parentheses? Sure you could. Look guys, here's 5, so I have x minus 5. Here's negative 4, I have x positive 4. Do you see that? So I've really not taught you anything. Now you see what I'm talking about. I'm not teaching you new stuff today. Well, maybe new stuff here and there, but for the most part, we're now taking this zero situation, we're looking at it from a different angle. In this case here, we're going backwards. So based on what I just showed you, I could write a polynomial function pretty quickly. Watch. Positive 2, so I'm going to put a negative 2. Positive 1, so I'm going to put a negative 1. Positive 5, so I'm going to put a negative 5. Now we're not finished. On your tests and quizzes, I will never allow you to leave your answer like this. You have to simplify it and multiply it through. So we're going to multiply our first two parentheses together, and we'll bring this one down. Now guys, listen, I love all the students I teach. I care about you guys, but we have done so many, x times x, x times negative 1, negative 2 times x, negative 2 times negative 1. I really don't want to reteach that, so I'm just going to show you what you would get. You would get x squared, negative 3x, positive 2, okay? That's what you would get if you took this parentheses times this parentheses, okay? So now I multiplied this times this, and I got this. Now take this times this. So your x squared gets multiplied through. You take x squared times x squared times negative 5, then negative 3x times x, negative 3x times negative 5, then 2 times x, and then 2 times negative 5. x times negative 5. 2 times x. 2 times negative 5. And there we go. I did it. Now let's simplify and we're finished. Always write your functions in standard form. And simplify them as far as possible. So x cubed comes first. Then negative 5, negative 3. That's negative 8 x squared. Positive 15, positive 2. Positive 17x. And then negative 10. Look at that. You just wrote a polynomial function and all that I gave you were the zeros. Now notice, when I say it has a lead coefficient of 1, if you'll do it the way I've taught you, that will always happen automatically. You won't have to worry about making that happen. You will always have a lead coefficient of 1. Okay? There we go. We did it. Let's try another one, okay? There's your zeros. Now we're getting to some imaginary zeros. Interesting, huh? Let's try this, okay? Here we go. I'm giving you this. Here's your zeros. I want you to write the polynomial function. So here we go. F of x equals positive 3, so I'm going to put a negative 3. Negative 3, so I'm going to put a positive 3. Negative 2i, so I'm going to put a positive 2i. Positive 2i, so I'm going to put a negative 2i. There, we did it. Now, all that we have to do is simplify. Hold on. Do not work ahead. Would you please trust me and not work ahead? If you're going to do it the way I taught you, here's what's going to happen. And you're going to regret doing it this way, so don't do it. Just watch. Multiply. Multiply these two first, and you'll get this. Trust me. So then you bring down your other two parentheses. No, don't do this. Just watch, okay? Just watch. So you multiply your first two parentheses together, and you get this. Now, students, what you would do next is you would take this parentheses times this parentheses, and oh my goodness, it gets so ugly. You're going to have x's, imaginary numbers, everything. So, Mr. Garrett, what do you want us to do? Here's what I want you to do. This is something brand new I've never taught you before, so would you please listen to me, okay? Whenever you're multiplying parentheses together, it's easier. Don't you like that word? It's easier if you multiply opposites together first. Now write that in your notes however you want to. It's easier if you write opposites first, or multiply your opposites first. So like, example, I have x minus 3x positive, a positive. Those are opposites. So multiply those together and you'll get this. Then these are opposites, x plus 2i, x minus 2i. Multiply those two together and get out an expression, and then go from there. I'm not going to go into detail why, but oh my goodness, it makes these problems so much easier. Now, do you always have opposites? Of course not. You didn't have any opposites back here. You had minus 2, minus 1, minus 5. So you're not always going to have opposites, but sometimes you will. And when you do, when you do have opposites, please multiply those together first. Okay? So here we go. I already did the first one for you. Right here. If you take x times x, you get x squared. X times 3 is 3x. Negative 3 times x, negative 3x. Negative 3 times 3, negative 9. And look, your positive 3x and your negative 3x cancel out, leaving you with x squared minus 9. Okay? So, multiply your first two parentheses together, and this is what you get. Now, this is going to be interesting here, so please follow along and watch me, okay? Because we've never done multiplication like this. Oh no, that's not true. We actually have done this already, but still, let's take a look at this and work this out. Now, if I multiply these two together, watch what happens. X times x, x squared. X times negative 2i, negative 2ix. 2i times x, that's positive 2ix. Now watch, positive times the negative is negative. 2 times 2 is 4. I times I is I squared. Hold it. What have I taught you? You can put for I squared. We learned this earlier in the year. Do you remember? Negative 1. So where the I squared is, put a negative 1, not I squared. And now, negative 4 times negative 1 is positive 4. Dudes, students, look. Negative 2ix, positive 2ix. What do? Cancel out, and you're left with what? you see now why you should multiply opposites together? The middle terms always cancel out. For this here, I had x squared minus 3x plus 3x minus 9. These two middle terms canceled out. That's why you should multiply opposites together first. It makes the problem so much easier. Now let's finish up. We multiplied these two together and we got this. Multiplied these two and we got this. Now let's multiply these two and we're finished. X squared times x squared, x to the fourth, x squared times 4, 4x squared, negative 9 times x squared, negative 9x squared, negative 9 times 4, negative 36. Combine those and we get x to the fourth minus 5x squared minus 36. Totally finished. There it is. There's my function. That function right there has these zeros right here. Right there. Now what about imaginary zeros, Mr. Eric? That's kind of weird. I know, but they do exist. Now, if you were to graph this function, you would have an x-intercept here. Remember, guys, what have I taught you? Zeros are the exact same thing as x-intercepts, okay? So if you were to graph this function, you'd have an x-intercept here, an x-intercept here, and what about these? They don't mean anything. Don't worry about it. These are your x-intercepts. So we did it twice now, guys. We've done it twice. We have wrote a polynomial function when I've just given you the zeros, okay? Alright, moving on. Let me throw a little curveball at you. I want you to try this one. Copy that in your notes. I want you to write a polynomial function with a lead coefficient of 1 that passes through these 2 points. Write a polynomial function with a lead coefficient of 1 that passes through these 2 points. Now, again, I'm not teaching you anything new here, just common sense. Come on, guys, stay with me and think about this. So your polynomial function passes through this point. Where would that be? Right here. And it passes through this point. Where would that be? Right there. Do you not see what I see? These two ordered pairs are what? They're x-intercepts. They fall right on the x-axis. So, these two ordered pairs that I've given you are really what? X-intercepts. And if they're really x-intercepts, they're also what? Zeros. Remember, zeros and x-intercepts are always the same thing. So, if you have x-intercepts of 1 and 4, then you have zeros of 1 and 4. So you're really writing a polynomial function that has zeros of 1 and 4. So we can do that. My goodness, we just did that for the past 2 problems. I gave you zeros, you wrote the function. I gave you zeros, you wrote the function. Here's the zeros. This is easy. Positive 1 is a 0, so you're going to put x negative 1. 4 is a 0, so you're going to put x negative 4. Now do your multiplication, and here's your answer. X squared minus 5x, positive 4. Booyah, done. There it is. Not too bad, guys. Okay. Alright, moving on. Now, let's jump on to another type of problem, okay? Now I want you to write expressions as products of linear factors. So copy that in your notes, please. I want you to write expressions as products of linear factors. Now, it's not too hard. I want you to sit back, take some notes on this, and just watch what happens, okay? The first thing I want you to do is I want you to factor this. Can you do that for me? I want you to factor this, okay? I'm going to show you why in a second. Just trust me, okay? So if you were to factor this, you would get this. Just take some notes, follow along, and watch. You would get this, okay? And then over here, pull out a negative 9. You're left with this. Now write your matching parentheses once, and you're left over with x squared negative 9. Okay? Now, I'm writing this as a product of linear factors. You should have no idea what that means, and I'm going to show you now. A linear factor just simply means you have a factor in which the exponent of the x is 1. So in this parentheses here, what is the exponent of my x? 1. Over here, what is the exponent of my x? 2. So this is a linear factor. This is not. So I have to take this a little further, okay? In other words, this is a linear factor. How do I know that my exponent's a 1? This is not, so I've got to factor this further. So bring down your x plus 5. Now watch this. This is a perfect square. This is a perfect square. The first term is positive, second term is negative. So I put two little parentheses. The square root of x squared is x. The square root of 9 is 3. Make one positive, make one negative. Now what is my exponent here? 1. What is my exponent here? 1. What is my exponent here? 1. We're done. Now I know what you're thinking. Mr. Harrow, this is dumb. We didn't do anything except factor. I understand that. But it's very important as mathematicians that you understand what a linear factor is and what it means when you're told to write an expression as products. That means they're multiplying of linear factors. And we did it. Now you understand these problems are about to get a lot harder, like here and here. Okay? 4th degree, 5th degree, but for right now, I want to drill this into your head. Are you ready? Here's what I want to drill into your head. When you're asked to write an expression as linear factors, you're going to have to break it all the way down into sets of parentheses in which the exponent of each x is 1. It's not going to be easy to do. Do you understand? Okay? But it's something we're going to try to do. So there's my answer right here. Here's my answer there. By the way, if you were to take this and multiply everything back through, you would get this right here, what you started with. Pretty cool, okay? So, having said that, that's what we're going to try to do. Now, I have a reason for doing what I'm about ready to do, so just be patient with me here. I'm going to tie all this together in the end, so I'm going to bring this along with me, okay? Alright, here we go. Put this right up here for now. Okay, now students, let's take this and let's write it as linear factors. Well, the first thing you're probably going to say is, so students, if we're going to write this as a product of linear factors, we're going to have to factor it, but we can't. It's a 5-term expression, but hold it. We just learned a second ago that if I know the zero of something, like if a 0 is 4, I can put it in a parenthesis negative 4, right? Remember that? So I just had an idea. I might be able to find the zeros of this and then write it backwards into a parenthesis. For example, listen to me. If I told you, let's say we tested a 0 and found out that 1 was a 0, well, that means one of the factors of this has to be what? If 1's a 0, then one of the factors has to be what? X minus 1, right? We just learned that. Whenever you know a 0, you can change the sign and put it back in to the parentheses, as long as you change the sign. So let's just stop here and write this as linear factors. And of course, the best way to do that is to what? Factor. But you can't factor, so we're going to have to list out the possible rational zeros and find one, okay? So here we go. I'm going to do this quickly. My lead coefficient's 1. My constant term is 16. So my factors of 1 would be 1. My factors of 16 would be these numbers here. 2 times 8, 4 times 4. We don't need the 4 twice, so there we go. Put all of these numbers over 1. So I would have positive negative 1, positive negative 16, positive negative 2, positive negative 8, positive negative 4. Alright? So there's my possible rational zeros. Okay? Okay? So let's test these and see what happens. Like I've taught you, always start with your smallest number. So 1. I go from 4, 3, 2, 1, constant term, so I'm not missing any numbers. Let's see if I get out a 0. Okay, here we go. Bring down your 1. 1 times 1 is 1, combine. 1 times negative 1, negative 1, combine. 1 times negative 16, negative 16, combine. 1 times 16 is 16. Booyah, we're good. So now stop and think for a second, please, students. What is one of your zeros? 1. So if 1 is one of your zeros, what's the linear factor for that? X minus 1. Remember, I just taught you that back here. If you know a 0, you can put it back into the parentheses as long as you change the sign. So, one of my zeros is 1. So I'm going to write the linear factor up here. So guys, I found one linear factor. I'm getting there. Okay, now, what am I left over with here? Well, my degree was a 4, right? Remember? So I'm left over with 1x cubed minus 1x squared minus 16x plus 16. That's my new polynomial function, okay? So here we go. That's my new one. So we'll pull that down here. No need to have all this stuff. This is factorable. Now listen, I would keep my list of possible rational zeros because I might need it to test in this function here. But this is factorable, so I'm good. I'm doing really good here. Okay. So I was dealing with this function here. Now I've broken it down to this. I found one of my linear factors. Let's factor this now. Pull out what's common in the first two. Pull out what's common in the second two. 16 goes into 16 and 16. Negative sign here, pull out negative sign. And you're left with this. Write your matching parentheses once. And you're left over with x squared negative 16. Now, I got another linear factor. Look at that, another one. You say, Mr. Eric, there's a repeat. Doesn't matter, you still got to write the repeats. So bring this, so here's a linear factor, put it right down here. Remember, I found that linear factor earlier. Now I've factored this and I have this. I'm almost done. This is a linear factor. This is a linear factor. This isn't. So I've got to take this one a step further, okay? So let's factor this. This is a perfect square. This is a perfect square. The first term is positive. The second term is negative. The square root of x squared is x. The square root of 16 is 4. Make one positive. Make one negative. Now bring down your first two parentheses over here. And we are home free. We did it. Booyah. There's my answer. Got it. Do you see it? So, I've written this entire function right here, my original function. I have written it with linear factors. Power of 1, power of 1, power of 1, power of 1. So I have 4 linear factors, and I'm good. I'm totally good. Okay? So, now I'm going to copy this. I'm going to show you something at the end you need to see, so we'll do that a little later, okay? So, there's my, next answer here. And I should have copied this one too, and brought this over. There we go. Alright, now, we've got one more to do. Don't hang with me. I'm going to make it pretty reasonable, okay? Watch this. Now, you can work ahead if you want, but there's a couple tricks to do you've not seen before, so be careful if you choose to work ahead. Now, let's find this. Let's write this as a product of linear factors, okay? We cannot factor it in 6 terms. So we're going to list out our possible rational zeros. Lead coefficient of 1, constant term of 4. My factors would be 1 and 4 and 2 and 2. But I don't need the 2 twice. Now put each of these numbers over 1, 1 over 1, 4 over 1, 2 over 1. I would have positive negative 1, positive negative 4, positive negative 2. Okay? So there's my list of possible rational zeros. I'm going to start testing these and see what happens, okay? So positive 1. I'm not missing any terms. 5, 4, 3, 2, 1. Constant terms. So I've got a coefficient of 1, negative 1, 3, negative 3, negative 4, and 4. Hopefully I'll get it 0. Let's see if we do. Okay, bring down your 1. 1 times 1 is 1. Combine. 1 times 0 is 0. Combine. 1 times 3 is 3. Combine. 1 times 0 is 0. Combine. 1 times negative 4 is negative 4. Combine. 0. Booyah. So 1 gave me out a 0. So one of my zeros is 1. Now I'm not trying to find zeros. I'm trying to find linear factors. So if one of my zeros is 1, then the linear factor would be, we'll put it down here, x negative 1. So I found a linear factor. I've also simplified this down to this. So I started off with a 5th degree, now I have a 4th degree. There's x cubed, x squared, x, and then a you probably don't look at that right away and see that, and you've got to try to factor it on your own on a test or a quiz. You have to try to factor. I get that, but I'm telling you now with my experience, I've done these for years. I can look at that and tell you that's factorable. Okay, so I don't need any of this. I don't need this. This is no longer relevant. I don't need that because this function, this expression here is not a function. This expression here is now this expression. Now, how do you factor this? Well, remember what I taught you. It's a trinomial. This exponent here is twice as big as this exponent here, so that's good. And my lead coefficient is 1. So what two numbers when multiplied together give me -4? When added together give me +3. Well, I'm thinking of these two numbers. If you multiply those two numbers, you get a -4. If you combine those two numbers, you get a +3. So put your two parentheses, and most of you want to do this. You want to put x +4, x -1. That's not right. Your middle term is x squared, remember? So it should be x squared +4, x squared -1. Okay? Now, remember I've got one linear function already. See it? Right there, I've already got it. Neither one of these are a linear function. This can be factored though, can't it? Perfect square. Perfect square. First term's positive, first term's negative. Booyah, let's factor this. Square root of x squared. X. Square root of 1. 1. Make one positive. Make one negative. Look at that. Two more linear functions. I'm doing great. Pull this right over here. Now I've got a bunch of linear functions, but hold it. So I'm done with this. It's gone. I factored it down to this right here. Okay? But hold it. What about this? Here's what I want to show you. What do you do when it's not factorable? But yet you can't keep it because your power's a 2. It's not a linear factor. So what are you going to do? Here's what you do. You take this parentheses that is not factorable. Got it? And you set it equal to 0 and solve like this. There you go. Now solve for x and watch what happens. Bring your 4 over and make it a -4. Got it? Take the square root of both sides. The square root of x squared is x. And the square root of -4 is positive negative. Square root of -4. Now, we learned this months ago. Whenever you have the square root of a negative number, you can make it positive. As long as you put an I on the outside. Okay? That's review. We should know that. Now, the square root of 4 is 2. So now x equals positive negative 2i. So we're good. Remember what I taught you. If you know a 0, you can go back in and substitute it in as long as you change the sign. So you took this parentheses, you set it equal to what? 0. You solved. So these are zeros. So if positive 2i is a 0, then you put over here x minus 2i. If negative 2i is a 0, you put x plus 2i. And now you've taken care of every parentheses. All of your exponents here are 1s for your x's. So you've written this entire expression right here. This big expression, no, not that one. This expression here, all into linear factors. If you were to do all the work and multiply all this back through together, you would get this right here. Okay, now I would like to show you something that's really, really important. Okay, we're just about done. The video's about done, but I want to show you something. It's really important. Okay, so watch this. Please, very carefully watch this. I hope it fits. It might not fit. I don't think it's going to fit. Let me shrink this down just a little bit. There. Now, just sit tight. Hold on, okay? There. Now, are you listening? I broke this down to this linear factors. I broke this down into this linear factors. I broke this down into this linear factors. Did you notice something about the degree of each function and its zeros? Let me show you if you didn't. The degree is 3. And the zeros for this, if I were to find all the zeros for this, I I would get negative 5, positive. I would get negative 5, negative 3, positive 3. How many zeros is that? 3. What degree do I have here? 4. My zeros would be positive 1, positive 1, negative 4, positive 4. That's 4 zeros. What's my degree for? What degree do I have here? 5th degree. Watch this. I have, my zeros are positive 1, negative 1, positive 1, positive 2i, negative 2i. That's how many zeros? 5. So write this sentence down, please. Write this sentence down. Well, this first sentence. When you include imaginary zeros and repeated zeros, the number of zeros will always equal the degree of the polynomial. Always. Would you please copy that in your notes? Let me say it again. When you include imaginary zeros like these two here, and when you include repeated zeros, like look here, for this parentheses I had positive 1 for a 0, and for this parentheses I had a positive 1 for a 0. When you include imaginary zeros like these and repeated zeros like these, the number of zeros will always equal the degree of the polynomial. 3 zeros, degree of 3, 4 zeros, 4 degree of 4, 5th degree, 5 zeros. That's as long as you include imaginary zeros and repeated zeros. One more sentence I would like you to write down. When a polynomial is broken down into linear factors, the number of linear factors will always equal the degree. How many linear factors did I have? 1, 2, 3. What's the degree? 3. How many linear factors did I have? 1, 2, 3, 4. What's the degree? 4. How many linear factors did I have? 1, 2, 3, 4, 5. What's the degree? 5. And that's it for today. It's been tough. I know it's a lot of stuff to learn. I know this material's not easy, but you can do it if you work hard, pay attention, take great notes, and work on the homework and really practice. Even if you have an A average and you're exempt from homework, I would very much caution you. I would really, really, really do the homework, okay? And practice, practice, practice. Alright? I hope this video's been helpful to you. If you have any questions, don't hesitate.